Albert Einstein is perhaps one of the most globally recognized scientists in history. But who was this man, really? Of course, many know him as a genius among geniuses. Others may think of him as the archetype for the genial, absent-minded professor. Some may know him as a flawed husband and father. Still others know him as a pacifist and an internationalist. Of course, being globally recognized, nearly all of us know something about his celebrity. In fact, as a human being making his way through life in interesting and challenging times, he was all these things and much more. But when I think of Albert Einstein, I think of him as the quintessential hero of a noble quest. That is the story that I wish to share with you. As Einstein's story begins, his quest was not at all clear and he seemed a very unlikely hero. But the arc of his life, as we shall see, is filled with both the characteristics of a hero mingled with aspects of ordinary life. After all, great heroes, even revered scientific heroes, are at their core human beings like you and me. Einstein was born in 1879 in Ulm, Germany. His parents were Hermann and Pauline Einstein. Both of Einstein's parents were of Jewish descent and followed Jewish traditions, but they were not deep practitioners of the Jewish faith. Einstein's father was an engineer whose job took his family to Munich a year after Einstein's birth. In 1881, Einstein's sister, Maya, was born, rounding out his immediate family. In addition to the rather ordinary family into which Einstein was born, his early behaviors as a child seemed to make him a very unlikely hero. He was considered odd and very slow to learn to speak as a child. In fact, his family worried that he might have some other developmental delays. His nickname as a child was the Dopey One. This all began to change when Einstein's hero quest was foreshadowed by a gift he received from his uncle. Einstein was 5 years old and sick in bed when his father brought him a compass from his uncle. Einstein would twist and turn the compass and noticed that no matter what he did, the needle always pointed to magnetic north. Later, Einstein would remark that his interest in science began with this compass, and his realization, through his observation, that something deeply hidden lies within, behind things. After his experience with the compass, Einstein began observing and thinking about many things in the natural world. He was fortunate to receive schooling at a Catholic elementary in Munich and receive private Judaism lessons at home. In 1888, he began attending the Luitpold Gymnasium in Munich. These experiences continued to stoke his interest in science. One idea that would shape his future quest came to him when he was 10 years old. Einstein thought about light, which he understood at the time to travel as a wave. The idea he had was, what would light look like if one could run as fast as a beam of light, or actually ride upon a beam of light? He realized it could not be possible to travel as fast as light, for if one could, why has no one observed a beam of light standing still? This type of thinking opened an entirely new world to Einstein. Although the possibility of Einstein becoming a hero was still in doubt, early visions of his quest were beginning to take shape. One step in the direction of becoming a hero was he also met someone who could be a hero's companion or helper, Max Talmay. Max Talmay was a 21-year-old student who introduced Einstein to key science and philosophy texts and taught him the fundamentals of differential and integral calculus, tools he would need on his quest. Typically, a hero discovers that he has some special power or weapon. Einstein's thinking about light was the beginning of his discovery of his own power. This time in Einstein's life had many events that were critical to shaping him into becoming a hero. Einstein's father and mother moved to Milan, Italy, to continue the family engineering business and left Einstein behind to live with relatives while he continued his education in Germany. In 1894, Einstein chose to leave the gymnasium without graduating and moved to Switzerland to enter high school. Concerned with increasing militarism of Germany at the time, Einstein renounced his German citizenship and became effectively a man without a country. Far from his home and family, attending high school in Switzerland, Einstein's special power emerged as the Gedanken experiment, or thought experiment. Einstein's unique approach was to avoid doing actual experiments or formalizing mathematics to understand a scientific concept. Instead, he would closely scrutinize the experimental results and formal equations of others, looking for some inconsistency or flaw in the explanation. He would then approach finding a solution or remedy to that inconsistency by approaching the problem conceptually. Or, in other words, he would think about what the inconsistency or flaw implied about the theoretical solution. Once he clearly understood the problem and thought through a solution, only then would he begin to formalize the mathematics, thus avoiding becoming lost in his equations before he knew where he was going. One of Einstein's early Gedanken experiments was an inconsistency he found in Maxwell's equation for electromagnetism. At the time, scientists thought there was an absolute reference in the universe called the ether. Maxwell's equation showed that if a magnet was at rest with respect to the ether, only a magnetic field existed. But if the magnet moved relative to the ether, an electric field would also be generated. This electric field would be experimentally detected by measuring current induced in a conductor encircling the magnet. Einstein's Gedanken experiment was to imagine riding on the magnet with the encircling conductor traveling along with the magnet. If there was an absolute reference for motion in the ether, then the conductor should have an induced current in it, since the magnet would be moving relative to the ether. The only problem was the encircling conductor experimentally experiences an induced current only if the magnet is moving while the encircling conductor is stationary, or the encircling conductor is moving while the magnet is stationary. In fact, Maxwell had to develop two separate equations for these last two possibilities. Einstein concluded that something was wrong if where someone, otherwise involved, was and how that someone moved changed the result of an experiment. For Einstein, the ether became a fiction, and the absolute measurement of motion ceased to exist for him. Thus, one had to consider the relative frame of reference when solving a problem involving motion. As Einstein attended university in Polytechnic Zurich, his quest was finally fully coming into his vision. Yet, much lay before him before he would become a hero. But clearly, noble quests place one's feet on the path of a fledgling hero long before the quest is complete. His religion turned toward what he would later call cosmic religion, that God was in the harmony of the world and the universe around us. In effect, recalling the compass of his childhood, he was seeking to understand God through the deeper meanings of how the universe worked. Einstein embraced his curiosity about the mysteries of the universe and sought to use his gifts and powers to enlighten himself and others about the marvelous structure of reality. Surely, this view of science takes on the qualities of a mythical quest. With his quest at hand, a special power developed, and helpers for his journey, Einstein turned to his guides, as any would-be hero must. His guides were great philosophers and scientists, who were successful heroes of their own quests. With respect to the ideas of relativity, Einstein sought out the knowledge of Aristotle, Galileo Galilei, Isaac Newton, and René Descartes. With respect to light and electromagnetism, Einstein sought out the knowledge of James Clerk Maxwell and Max Planck, all great science heroes who came before him. Of course, there was more to Einstein than just science. While at Polytechnic Zurich, he met and fell in love with Mileva Maric. She was Serbian and a strong personality with a scientific mind herself. Einstein's parents did not approve of this match. Mileva and Einstein's early relationship suffered many complications and tragedy. Having become a Swiss citizen in 1901, Einstein and Mileva spent time together with her more approving family in Novi Sad, Hungary, where she becomes pregnant with Einstein's child, giving birth to Lieserl in 1902. With Einstein having few prospects, Mileva and Lieserl stay in Hungary with her family. Although history is silent on her exact fate, Lieserl caught the scarlet fever in 1903 and likely died within a year. One of the reasons Einstein's prospects were poor is his hero's path had crossed that of a shadowy other who would shape his circumstances, Heinrich Friedrich Weber. All heroes encounter others who thwart their journey. Weber was a shadowy other, perhaps, of Einstein's own making. Weber was Einstein's and Mileva's graduate advisor at university. At the time, Einstein was a headstrong individual who believed that Weber was an outdated professor, far behind the times in science. As a result, Einstein unwisely skipped Weber's classes, or would challenge him when he did attend class. Ultimately, Einstein would transfer to another graduate advisor at university. Weber never forgot Einstein's cockiness and insults, giving Einstein poor recommendations that likely kept Einstein from graduating in a timely manner and landing a teaching job at university. Fortunately, another hero's helper arrived on the scene, Marcel Grossmann. Einstein had met Grossmann at university, and they had become good friends. Grossmann's family was well connected in Switzerland, and he encouraged Einstein to apply and helped him obtain a job at the Swiss Patent Office. With this job, Einstein was able to support his family, and he had the time to read scientific papers, conduct his Gedanken experiments, and write his own scientific papers for publication after he completed his patent examiner job for the day. With this good turn of fortune, Mileva was able to join Einstein, giving birth to their son Hans Albert in 1904. She would later give birth to their second son, Eduard, in 1910. With everyday life falling in place for Einstein with the help of Grossmann, his emergence as a hero finally takes place, and the Annus Mirabilis, or Miracle Year of 1905. In that year, he published 4 papers that changed the course of mankind's understanding of the inner workings of the universe. The first paper, founded in his curiosity about how light behaves, was about the photoelectric effect, as described in the following video.
Newton had thought light was made of particles, and his rival Hooke had thought it was a wave. And when technology advanced enough, some experiments proved Hooke was right. That proof, and Maxwell's equations describing light's behavior as a wave, made the debate die down, until the photoelectric effect was discovered. When light hits a cable next to another cable, electrons jump from one to the other. It was thought it happened because waves of light made atoms vibrate until they ejected an electron. But when it was measured carefully, a big contradiction was found. It only happened for light of some wavelengths. For others, no electrons jumped at all. Einstein was bewildered. The photoelectric effect should work regardless of the type of light. If light wasn't made of particles, and now it turned out that it couldn't be made of waves, what was it made of? After much reflection, he formulated a new hypothesis combining the 2 previous ones. What if light were made not of waves or particles, but of both? That is, what if light were made of wave packets? That concept, which we now call photons, allowed Einstein to write out equations that explain the photoelectric effect in 1905. This consolidated the idea that light can sometimes be described as a wave, sometimes as a particle, and sometimes as either. It was a revolutionary view, and it opened the field for quantum physics.
Einstein had revolutionized the scientific understanding of light and, along with Max Planck, opened the door to quantum mechanics, the most successful scientific theory that revolutionized modern life. Unfortunately, as questing heroes are wont to do, Einstein set in motion a series of events with respect to quantum mechanics that left his control and later would present a challenge that would consume him for the rest of his life. Einstein's second paper was on Brownian motion. Brownian motion was a concept involving the spontaneous movement of very small particles. Without dwelling upon the details, this paper by Einstein ultimately did nothing less than factor heavily into nearly all scientists embracing the existence of atoms as physical particles, which was not a commonly held belief at this time. The third paper, also founded in his early curiosity about how light behaves, was about special relativity, as described in the following video.
Someone watching a car accelerate toward light speed would see something very strange. It would seem as though the car itself was getting shorter and that time for the person in the car was slowing down. However, you wouldn't see these effects until the car began to approach the speed of light. At 90% of the speed of light, the car would appear to shrink to 44% of its usual length. This thought experiment answered Einstein's old question about what he would see if he traveled along with a beam of light. He simply couldn't make the trip, for at the speed of light, length would contract to 0 and time would stop.
Special relativity changed how we think about space and time, solving a problem that had been considered for centuries by many great heroes of science. Einstein supported his own theory by showing his theory of special relativity explained a small deviation in the orbit of the planet Mercury due to the sun's gravitational mass present there. The fourth paper came directly from Einstein's theory of special relativity, yielding his most famous formula, E equals mc squared, as described in the following video.
In mid-1905, Albert Einstein derived what is now the most famous equation in the world, E equals mc squared. But he didn't just write this down out of the blue. It followed directly from his paper on special relativity that we talked about in last week's video. And here's how he did it. Suppose you're watching a cat float freely in empty space, when suddenly it emits a flash of light in all directions. The light carries away some energy, we'll call it E. So by conservation of energy, the cat must have lost energy E. But since the light was emitted symmetrically in all directions, it won't have changed the cat's velocity. So where did the energy for the light come from? Never mind that now. Let's imagine you get bored and zoom off in a spaceship in the middle of the experiment. But from your new perspective, you're sitting still in your spaceship, and the cat is the one moving past outside the window. Therefore, you'll calculate that the cat has some kinetic energy, that is, energy of motion. And when you see the cat emit the flash of light, you'll again measure that its energy decreases by the energy of the light. Except now that you're moving, special relativity tells us that time passes at different rates for you and the cat, so you'll measure a different value for the frequency, and thus energy, of the light. This is the relativistic Doppler effect, and for our purposes, it amounts to multiplying the energy of the light by 1 plus your velocity squared divided by twice the speed of light squared. So to recap, if you take off at velocity v, you'll see the cat gain some kinetic energy ke1, then at the flash, you'll see the cat's energy decrease by e times 1 plus v squared over 2c squared. On the other hand, if you wait, you'll see the cat's energy decrease by e, and now when you take off, you'll see it gain kinetic energy ke2. But this is silly. You never touch or otherwise influence the cat in either case, so we should get the same total energy at the end. Rearranging, we see that the kinetic energies before and after the flash must be different. And the kinetic energy of an object is 1/2 of its mass times its velocity squared. But we know that the velocity was the same in both cases. So in order to account for the difference, the cat's mass must change when it emits the flash of light. Now, if we cancel things out, you can see that the change in mass of the cat must be equal to the energy of the light emitted divided by c squared. Or, as you've heard before, E equals mc squared.
This equivalence between energy and matter ultimately opened the door to the potential of nuclear fission and nuclear fusion. Einstein's 4 scientific papers in 1905 cemented his role as the hero of a great quest. Of course, great quests are rarely accomplished alone, and again, Einstein had many helpful companions. Among Einstein's helpers, once again, was Marcel Grossmann, joined by Michel Besso. Both of these men were good friends from Einstein's time at university, playing critical roles in helping Einstein formulate the formal mathematics of his theories. Hermann Minkowski was actually one of Einstein's professors at university. Working from Einstein's theory of special relativity, he is the person who actually realized that time acted as a fourth dimension, leading to the idea of space-time. Just as heroes on quests need helpers, they also need competitors to spur them on. Henri Poincaré and Hendrik Lorentz were scientists that pursued many of the same ideas that Einstein brought forth in his special theory of relativity. In fact, the contributions of these scientists to Einstein's work is so impactful, they may also be considered as guides and helpers on his quest. Not satisfied, and driven to pursue his quest still further, in 1915, Einstein published his general theory of relativity, which further revolutionized mankind's understanding of the universe, as described in the following video.
In one of Einstein's famous thought experiments, he realized that gravity and acceleration appear to be the same phenomenon. Think about what would happen if an elevator suddenly went into a free fall. The person inside would effectively weigh nothing. Next, imagine that same person in a motionless rocket ship, so far from Earth that the force of gravity is practically zero. Just like in the free-falling elevator, he would also weigh nothing. Now, put the rocket in motion. As the rocket speeds up, the passenger's weight increases. To him, it feels just as if gravity had planted his feet firmly on the floor. Einstein realized that the force of gravity is just the acceleration that you feel as you move through space-time.
This next video describes the implication of Einstein's general theory of relativity for our understanding of our universe.
If there were nothing in our universe, the fabric of space-time would be flat. But add a mass and dimples form within it. Smaller objects that approach that large mass will follow the curve in space-time around it. Our nearest star, the Sun, has formed such a shape in space-time, and our tiny planet Earth goes along for the ride, staying in orbit around the Sun.
The equating of the effects of gravity and acceleration by Einstein extended his ideas of special relativity to the more general case. The implications of this general theory of relativity raised Einstein to the level of a hero among heroes. Of course, there is no end to the number of helpers that the hero had on this quest. One helper that stands out particularly with respect to Einstein's general theory of relativity is Arthur Eddington. Eddington was an astronomer who took on his own great quest to travel to a dangerous remote location during World War I in 1919 to observe the eclipse that proved Einstein's theory that a large gravitational mass, like the Sun, was able to bend light. The publication of Einstein's special theory of relativity in 1905 was widely read and not surprisingly placed many other scientists on the path of discovering general relativity. Einstein's closest competitor was perhaps David Hilbert, who had a working general theory of relativity ready for print within days of Einstein's publication. Also on a similar page to Einstein's pursuits were Bernhard Riemann and Ernst Mach. In fact, these competitors were so close to Einstein's trail that his work took on an excessive pace in the final days before Einstein's publication. That excessive pace may have contributed to Einstein's divorce from Mileva in 1950. It certainly contributed to a physical collapse that Einstein had in 1916. At that time, Einstein's cousin Elsa came to nurse him back to health. Again, the hero's quest is echoed in our hero suffering a serious wound as he accomplishes a great task. Upon his recovery, Einstein married Elsa to be his second wife, and she became a lifelong supporter of his quests. As is often the case, the success of a great hero brings out those shadowy others who would see him fail. Two shadowy others that appeared after Einstein's great successes were Philipp Lenard and Johannes Stark. Both were German nationalists who had won Nobel Prizes and supported Hitler in the rise of the Nazi Party in Germany. Lenard, in particular, attacked Einstein as a promulgator of Jewish physics, designed to confuse and distract from the pure German physics. Although these efforts came to little outside of Germany, they in part, along with the rise of Hitler and the Nazi Party, prompted Einstein to ultimately leave Germany and Europe to become a refugee in the United States in 1933, after which Einstein never returned to his country of birth, Germany. Einstein, now the triumphant hero having completed his major quest, begins to receive his rewards. In 1921, he receives the Nobel Prize in Physics. Oddly enough, not for the work in special relativity or general relativity, but for his work on the photoelectric effect. This, of course, cemented his fame as one of the greatest scientists of all time, and gave him even greater global celebrity. Although he had divorced Mileva in 1950, he made good on his promise at the time to give any financial compensation from the Nobel Prize that he won to support her and his sons. So, what does one do when they become a hero? Well, of course, they act heroically. Einstein had been a pacifist all the way back to when he renounced German citizenship at 17 to avoid military conscription. Continuing his pacifist stance in 1918, he rode in a car with his wife Elsa at the front of the Peace March in Germany. Not a particularly safe thing to do in Germany during World War I. Published in 1921, Einstein wrote a manifesto to Europeans, pleading for European nations to cast aside militarism and to seek peaceful unification of the governments of Europe. Despite a lifetime of pacifism, in 1933, Einstein abandoned his course for non-resistant pacifism and advocated a course of preparedness to counter the growing threat of Hitler and the Nazis. While this did not make Einstein's pacifist friends very happy, a hero must recognize when it is time to change course and speak their minds, no matter how unpopular the words. Despite having never been bar mitzvahed and not practicing Judaism, in 1918, Einstein lent his name and support to the founding of Hebrew University in Jerusalem, supporting the Zionist movement for Jews seeking a homeland. This was not a popular decision and likely cost Einstein many so-called friends, but a hero must do what he thinks is right, despite the cost. In 1939, a group of physicists asked Einstein to use his global celebrity and status to write a letter to the then U.S. President Franklin Delano Roosevelt about the potential of creating a nuclear superweapon. Further, Einstein warned of potential progress on such weapons in Germany under Hitler and the Nazi Party. As a result, Roosevelt initiated the Manhattan Project, which won the race against Germany to develop the first atomic bomb. Interestingly, Einstein was not allowed to work on the Manhattan Project, possibly due to a 1,400-page FBI file on Einstein that likely cast suspicions on Einstein's loyalty to the United States due to his support of pacifism, internationalism, and Zionism. Having witnessed the destruction of the war, and especially the creation and use of nuclear weapons, Einstein returned to his pacifism and internationalism. In 1955, just before his death, he joined Bertrand Russell in issuing a manifesto to the world, pleading for the move towards world peace through unification of world governments. A hero can always go home to his beliefs. Of course, Einstein may have been a hero, but he was a human being at his core. He took great pleasure in his celebrity and rubbed elbows with famous people like Charlie Chaplin and Marilyn Monroe. Celebrity can also be taxing, so the classic image with Einstein sticking his tongue out at reporters is quintessentially human. Einstein would often jokingly say, when people would come up to him, something to the effect, "Oh no, I just look like that Einstein fellow." Although the general theory of relativity would have been an ending worthy of a great quest, this was not the finish of Einstein's work. In 1927, he attended the Fifth Solvay Conference, an exclusive meeting of the world's greatest physicists at the time. There he met with Niels Bohr and began working on a bit of unfinished business that he had helped create with his work on the photoelectric effect, namely the theory of quantum mechanics. For many years, he and Bohr debated different interpretations of the quantum mechanics theory, a theory whose implications were at odds with Einstein's fundamental belief in a deterministic universe where all problems ultimately have definite solutions. And so began Einstein's final and greatest quest, finding a unified field theory that would tie together general relativity and the quantum mechanics theory. His aim was to define what he believed would be the correct interpretation of the quantum mechanical theory that would ultimately return scientists to the belief in a deterministic universe. Sadly, although Einstein continued to labor in his final quest and made many remarkable contributions to physics to the end of his life on April 18, 1955, the hero was unable to accomplish this last great quest. So, was Einstein still a hero after failing this last great quest? I say unequivocally so. He was and is one of the greatest scientific heroes. Just as Einstein relied upon the guidance of great heroes of science who did not complete all of their quests, Einstein becomes a great hero and guide to all those who follow. My cases on point are the many contributions scientists have made to our modern world by building upon the work of Einstein and, of course, others. Gravitational lensing, gravitational waves, Schwarzschild's black holes, Shockley's transistors, computers, telecommunications, electron microscopy, magnetic resonance imaging, and global positioning satellites. The reality is the pursuit of science is a never-ending quest that requires generation upon generation of science heroes to move progress forward. To play a part, great or small, as one of those heroes is enough to enter the pantheon of science heroes. Perhaps there is a place for you among those heroes, if you will but take up the quest yourself.
Bye.